listen-only mode.
Good morning, everyone. My name is Scott Garlington, and welcome to the review of the 7180. Hopefully everyone can see the slides here. This is the webinar to introduce the AP7181, the 802.11n outdoor product. As I said, my name is Scott Garlington. I'm the product manager of the Mesh Network product group. I'll be going over some of the market drivers and the technology that we've designed the 7181 around. Bill Rubino is going to go over the supporting portfolio of the 802.11n products. And Rosalie Babona is the product manager, and she'll be going over some of the details and specifications of the 7181. We also have MWAN with us, who's a product management on our team, and he's going to be trying to answer your questions as you submit them online in real time. We'll also gather up some of the more common questions and answer them at the end of the seminar. So there's a couple of ways you can submit those. One is to, in the chat mode, you can chat to staff, and we'll see them. Or if you have a questions bar on the webinar bar that you see there, you can also submit them through the questions. So feel free to submit questions. If we don't get a live answer to you, summary answer at the end, we'll make sure we'll get the answer to you via email. Okay. Before I get started into it, I did want to, for those that aren't familiar with the Mesh Network product group, the team has been developing outdoor Wi-Fi products since 2000. We support some of the largest and oldest networks deployed, like Providence, Rhode Island, Plano, Texas, and Cocoa Beach, which was actually the very first citywide Wi-Fi deployment. The engineering team has developed over 140 patents in the outdoor mesh space and has somewhere around 450 pending patents. So we've been at this quite a bit. That's what our focus is. It's what we do. Oops, I'm sorry. Let's go back one more. Okay, so as the screen's update here, let's take a look at the market trends. Today we are seeing real upward trend in outdoor Wi-Fi deployment. Here are just a few of the recent articles that validate the interest and what we are seeing in the market. Video surveillance and the demand for higher bandwidth, mobility for public safety and transportation, multi-use city-wide deployments that support many city departments. All these drive justification with real ROI. And everyone is looking to see what .11n will provide. Applications is what drives the payback of these networks. As you can see in video surveillance, there's a number of applications around that, from fixed cameras to red light cameras, public transit surveillance, where we have cameras on buses and trains these days, workforce mobility, police officers, utility vehicles, all need mobile offices. And a big uptake, what we're seeing is command and control or monitoring control with meter reading, smart parking. A good example of this is that has been recently deployed is a city here in Florida, Hollywood. There's a 29 square mile city that has deployed about 400 APs at this point. The total will be around 700 APs. The total cost of the project was $13 million. About $2 million of that was for the access point. So the access points not only drive services, backhaul equipment, and everything, but it's a substantial uptake when these networks go in to drive additional revenue for the services and the products. They expect to have payback on this within, I believe, 2.5 years. And the total savings that they'll have from the services and and capabilities that they're deploying is $23 million over a 15-year period. So those are some of the drivers that we're seeing, quite substantial, all around local, high bandwidth broadband networks. But let's look at what .11n standard is doing. If you haven't heard, it's been ratified this month. It was expected to be ratified January 2010, but it's been ratified around the Draft 2 revision. So all the products, most of the products out there today are Draft 2 compliant. The Wi-Fi Alliance has already certified over 450 Draft 2 products, and Intel has shipped 3 million .11n clients. So .11n is already prevalent in public safety, education, healthcare, manufacturing, and professional services. The overall growth of the .11n market in the outdoor space and from a Wi-Fi perspective, as you can see, the graph, the yellow graph shows the trend in Wi-Fi devices shipping .11n products. By 2012, over 90% of all Wi-Fi products will use .11n. The green graph shows an upward growth of the outdoor meshing networks. Dell'Oro is the only analyst that has tracked this specific market, and as you can see, it's had a little bit of a downturn over the last couple of years. That was due to some of the Muni Wi-Fi failures, which really focused around providing free access. That wasn't a model that worked, and that's why we just went through what the cities are seeing. A model that works is true ROI, or a real payback where they can justify the networks. And the interesting thing here is that Dell'Oro sees almost a 40% growth in 2010. So we think we have the right product at the right time. Some of the key technologies that we want to talk about, just to make you aware, what does .11n bring to the table? MIMO, I think everybody's heard about that. It's the ability to transmit and receive multiple in, multiple out. Spatial multiplexing is a key. It allows for dual data streams or multiple data streams. Packet aggregation, where it reduces the amount of headers on the packets and increases the payload across the channel. And channel bonding, being able to take advantage of the full 40 megahertz. A lot of these features and technologies, as .11n is designed around an indoor network. Having the ability to use 40 megahertz in an outdoor space is going to be difficult. A number of things change quite a bit in the outdoor environment. So when you talk about .11n, it's not just MIMO that brings the advantage, and especially in the outdoor environment. You need MIMO, you need spatial multiplexing, a good packet aggregation algorithm, and channel bonding. So you need them all. One of the key things, as I talked about, is MIMO and spatial multiplexing. You'll see terminology like 3x3x2. This refers to number of transmit antennas, number of receives, and number of data paths. The 3 relates to the multiple transmits, which is CSD. And this requires, to take full advantage of this, both the transmit and receive to have multiple receive antennas to maximize the delivery of free transmission. On the receive side, it's referred to as MRC, or maximum ratio combining. This is increased receive sensitivity, which is the more powerful of the two, where if you can receive the signals on all 3 channels, even a device transmitting with a single stream will be heard better. So this works with both MIMO and non-MIMO clients, which improves even BG-type clients connecting to the network. And finally, the spatial multiplexing, which is the ability to transmit dual data streams, simultaneously transmitting the different streams at the same time, which can have the effect of doubling your data rate. Here is an example of 40 megahertz channels, the type of data rates that you can get to on a single stream with .11n is 157 megabits, where a dual stream is double that at 300 megabits per second. So in order to get to the pure 300 megabits per second, you really need all three of them. I'm going to take some time here to introduce you to the 7181. This is a picture of it mounted here in Lake Mary. The AP71 uses 3x3x2 MIMO to utilize all of the .11n capabilities. Each radio delivers a full watt of RF power. The ADEPT antenna is custom designed to deliver the highest performing omni coverage on all radios. MeshConnex is the best-in-class routing algorithm and provides network stability. It is also supported by one-point wireless suite for network planning and management. And when deployed with the 7131, provides true indoor-outdoor networking. We will talk a little bit more in depth on the product specifications towards the end of the webinar. So from a go-to-market point of view, there's three things we want you to remember: 0, 300, and 1. 0 stick antennas for not only the best antenna coverage, but also for best aesthetics. Remember, if you have an equivalent product with 2 radios running 3x3, you have 6 antenna sticks coming out of that box, which is pretty difficult to deploy anywhere. 300, the AP71 provides more system capacity at a 300 megabit in the mesh layer. We'll talk a little bit more why this is key and unlike any of our competitors. And one complete indoor-outdoor solution, one network management solution, and one company, Motorola, that brings them all. So let's talk a little bit about the ADEPT antenna system. This is a unique antenna system that has been designed specifically for the 7181. It's a custom, only available from Motorola. It provides dual streams support by providing dual polarized antennas. .11n standard is based on indoor environment. It counts on reflections and multipath to achieve high data rates and take advantage of dual streams being transmitted. In the outdoor environment, there are limited reflections and extreme multipath delay. Therefore, the AP must deliberately inject diversity by using horizontal and vertical polarized antennas. The AP7181 provides both horizontal and vertical polarization on each panel for each radio. Self-shadowing avoidance. As I mentioned, traditional stick antenna AP will have 6 to 9 possibly of our 3 radio antennas closely correlated next to each other. This creates extreme gain and shadowing of the co-located antennas. This, in fact, creates a very unpredictable coverage path. Using the ADEPT antenna system, we provide a symmetrical, uninterfered antenna pattern, fully omni. And software electric downtilt is a capability where normally you would is a deployment tool that is used when you want to get better coverage down towards the ground and be able to get more client coverage or avoid co-location of APs interfering with each other in the 2-4 band. We provide that as an electronic down tilt that can be controlled through the GUI or the network management system. So it can be all the deployments can be the same, and then the network can be fine-tuned after it's deployed. So that's a quick summary of our ADEPT antenna capability. Let's talk a little bit about the 300. Why is it important to have 300 megabit capability on the mesh backhaul? First of all, it does a number of things. As we talked about, the more applications you need, the more clients, the more users you have on the network, the more demand you have on the backhaul or the mesh layer. Having high capacity on the mesh layer provides quicker growth, quicker ROI or return on investment, and avoids outgrowing the network or future-proofs the network capacity for the long term. The AP71 does this by offering a true 3x3 implementation on both the 2.4 and the 5.8 radios. This allows us to get to the dual data streams. The horizontal-vertical polarization allows us to take advantage and use the dual data streams in the outdoor environment. Our full-powered radios allows the nodes to be separated and still maintain a strong link between connectivity, so you can ensure that it has maximum data rate. And on top of that, we use a couple of Motorola-specific tools or features. One is to optimize the rate control, and the other one is called MeshConnex, which optimizes the routing algorithm. We'll talk a little bit more about each of these. And then the WAN. One company bringing together one network, making it all look seamless. One point wireless suite provides planning, deployment, and management, air defense security, and along with Motorola's VARs and partners and service organization provides complete service and support. So we have what we feel is the ideal outdoor access point. We feel we have a best-in-class indoor access point. When you combine those for a seamless indoor-outdoor solution and you bring together the backhaul of point-to-point, multi-point, best-in-class handheld mobile computers, voice headsets, the applications, the appliances, the servers, all tested as one solution and brought to you from one company. The next slide is going to take a look at some of the performance gains that you'll see when using .11n. First of all, let's look at the client side. Here's some test results that we did. And as you can see, and what we did here was, at the AP location, we first tested with standard-based clients, the 11G, and we tested that against a traditional DG access point in the 2.4 range. What we saw, then we replaced that same access point at the same locations with the AP7181. As you can see, significant differences. At location 2, where it was greater than 0.5 miles, we had almost 4 to 5 times the data rate, going from 0.5 megabits. BG networks, an AP client's going to add significant improvements. This is going to not only drive more throughput, but it increases the range, so you'll have more clients all accessing the single access point, which in turn, again, drives more demand on the backhaul. So this only works if you have a backhaul system in the mesh that is capable of supporting the additional client and throughputs. So what we show here is a kind of a heat map of planning tool from Broadband Planner that would indicate 2 deployments being planned, one with the capabilities of BG and then one with the range and power of the 7181. As you can see, there is significantly fewer nodes and also higher amount of red and yellow in the graph to show that the AP71 has fewer nodes and fewer but more throughput coverage. To simplify this, view, it really ended up being about a 2-to-1 ratio in that design, giving the 7181 a significant fewer cost, fewer nodes. This not only reduces the number of nodes, but reduces the total cost of ownership. Although the 7181 will be a bit more expensive than the traditional DG node, you also have to take into consideration the installation cost, the maintenance cost, and the backhaul. So a .11n network, we expect to be a lower total cost of ownership than traditional DG networks. Yeah. So the AP71 does this, and one of our key advantages in the marketplace is we've focused on the backhaul and being able to deliver a 300 megabits dual stream and take advantage of being able to have higher data rates and greater distances between the nodes. What we've seen is on many of the competitors, they offer a MIMO 3x1 or 1x3 on the 2.4 side, but only a single stick antenna or a traditional one stream on the backhaul. I think they've missed the point. As you can see with just a single stream, as we talked about, even in 40 megahertz, which is going to be tough to utilize it in the outdoor environment without MIMO, they'll gain 157 megabits theoretical burst rate. But by using dual streams and the vertical horizontal polarization to get true diversity, we can hit the 300 megabit burst rate and data rate. As I mentioned earlier, one of the other key advantages with the 7181 is that it makes use of MeshConnex. Out of that 140 patents that we've developed are all around MeshConnex. It uses a hybrid routing capability where it takes the best of both proactive, which is always knowing the best route to use, and reactive, where it only maintains the neighbor list. The hybrid solution, therefore, always knows the best, all of its neighbors, and on a per packet basis, can determine the best route. So it's very proactive from knowing all its neighbors, and very reactive because it looks at every packet and determines the best route. It looks at a number of things within the route. Most routing engines will only look at RSSI. MeshConnex looks at RSSI, packet loss, number of hops, amount of congestion on each link, and again, on a per packet basis, will determine that route. So in the end, it has a very fast convergence to the best route. Many outdoor APs will have some significant slowly converge to your route if something happens in the network. The real difference between indoor and outdoor is that the outdoor networks have a lot of variation in them. It's not a controlled environment. There's changes happening all the time, from reflections off of trucks going by to wind blowing trees in the way to rain. So it's a constant varying environment. MeshConnex, along with ORLA, which is our rate adaptation algorithm, are used to maintain the highest possible data rates and stability in the network. What this chart shows on the bottom here, the red line, is your normal chipset will basically determine the data rate. It will always start up and try to give you the highest data rate. When it starts getting collisions in the network, it rapidly drops down, but is very slow to come back up to the higher data rates. And then when it gets more collision, it rapidly drops down. So the overall normalized data rate selection that you have just off the chipset is what that graph shows. With ORLA, as soon as it drops down, it aggressively tests the higher data rate, so to see that it can get back up to a more maintainable high data rate. And therefore, it will constantly give you a higher data rate selection. Therefore, between ORLA and MeshConnex, they're on top of the .11n capabilities, give you the best-in-class access point. So I'm going to turn it over to Bill Rubino now, who's going to talk a little bit about the portfolio of access points and how we manage those and have seamless connectivity indoor-outdoor. Bill?
Thank you, Scott, and good morning, everyone. What you're seeing on this chart is our comprehensive portfolio of access points that serve both the indoor and the outdoor markets. Motorola's solution for this is we design these for wireless networks regardless of the size of the business. We've deployed large outdoor municipalities that we deployed all over the world, all the way down to branch offices and small businesses, delivering standard wireless coverage to virtually all types of networks, both indoor and outdoor. Motorola's innovative wireless portfolio includes standard-based 802.11a, B, and G, and now the new ratified .11n standard for enterprise wireless LANs for indoor networks, all the way up to outdoor wireless mesh access points, such as the MWAN 4300 and what we're talking about today, the AP7181. In the next few slides, we'll discuss how the AP7181 is compatible with the outdoor MWAN 4300 and the wireless LAN AP7131. So for those of you who are not familiar with the MWAN 4300, this is part of our outdoor wireless mesh portfolio. This is a dual radio access point that supports 802.11a, B, and G and features standard QoS for traffic prioritization, as well as Motorola's patented MeshConnex advanced routing protocol that Scott had just discussed. The MWAN 4300 is designed for large-scale outdoor networks that require 802.11a, B, and G connectivity and coverage. In addition to that, we have the MWAN VMM, which is our vehicle-mounted modem. This provides extended wireless coverage to vehicles and trains in metro rail systems. In terms of the compatibility of the AP7131 and the MWAN 4300, Motorola offers this compatibility between both of these. This will allow an outdoor network to deploy a mixture of AP7181s and 4300s. With this mixture, this will enable .11a, B, and G clients to roam between the 4300s and the 7181s, with the .11n clients connecting to the 7181. For mobility requirements, the VMM, the vehicle-mounted modem, will provide connectivity to vehicles that are moving up to 75 miles an hour or metro rail systems that are within the coverage area of this mixed network. The VMM is also compatible in an all 4300, an all MWAN 4300 network, or you can also use it in an all AP7181 network. Lastly, this can all be managed through our common management platform, Wireless Manager. So let's talk a little bit about the indoor product for .11n. This is the AP7131, which is a tri-radio .11n based access point. The AP7131 is designed for indoor networks providing standard .11a, B, and G, and now the newly ratified .11n wireless standard. It provides wireless coverage for enterprise networks. The AP7131 complements the AP7181 by providing indoor coverage, with the AP7181 extending that coverage to the outdoors. On this slide here, this is a typical use case that demonstrates the indoor to outdoor wireless connectivity. In this example, on the left-hand side, you have a warehouse that has deployed AP7131s indoors for connectivity to the .11n clients. They want to extend this coverage to the outdoors for parking lots, which you'll see here on the right. By deploying the 7181s outdoors and connecting the network indoors to outdoors, you now can extend the .11n coverage indoor to outdoor. by specifically designing the network to have common elements such as the same IP subnet, the same SSID, and the same security parameters, a client can now seamlessly move indoor to outdoor and vice versa. So with this solution, the combination of the 7131 and the 7181 in the outdoor environment, you now really have a powerful solution to actually extend that coverage indoor to outdoor. In terms of the management of this, OnePoint Wireless Manager allows for the configuration and then in the inventory management of the outdoor AP7181 networks. Wireless Manager in real time will display network statistics, alerts, and alarms for the network. The network elements, such as the 7181, can be dynamically displayed by the embedded Google Maps feature and include estimated coverage areas for the outdoors. In addition, the indoor AP7131 deployments are also visible via the Google Mapping feature in Wireless Manager and are summarized in the network map, and the wireless LAN nodes can also be configured through the click-through configuration feature that we have embedded in OnePoint Wireless Manager. In terms of the indoor to outdoor management, the RF management suite can be used. For customers and partners who have typically deployed indoor networks, the RF management suite, RFMS, will have the capabilities to manage and configure the 7181 as well as the indoor access points such as the 7131. This will allow you to create a seamless management suite. RF management suite allows for the network planning and management of deployed networks for the indoor wireless LAN APs. Customer reports can also be generated, and visualization, channel and heat maps are also available as well. So I'm going to turn this over to Rosalie Babona, who is the product manager for the 7181, and she's going to discuss some of the specifics about the 7181 access point. Ro?
Thank you, Bill. Good morning, everybody. First, I'd like to just cover a few of the highlights of the 7181. You heard a lot about it so far from Scott and Bill, but I'd just like to touch on some of the hardware aspects. It's 802.11 ABGN radio. It's a dual radio configuration, so it's a 3x3 MIMO on the 2.4 and a 3x3 MIMO on the 5.x, I call it, basically because that is configurable based on country code. We're rated for harsh environments. It's an IP67 rating with a NEMA 4 enclosure. We talked a lot about the in-depth panel antenna system for outdoor environments. That's the advanced element panel technology, where we're doing true dual diversity polarization to get to that second data stream, which is key in an outdoor environment. We basically have two 1 gig Ethernet ports that can be configured, for example, on the wire, or if you want to plug multiple cameras in. We have an integrated PoE 802.11 3AF out. You typically want to put power over Ethernet cameras on there. 20 and 40 megahertz channels, that's a given on the N standard. We also meet the current European DFS standards for 5.4 and 5.8. So just some highlights of the software features and the security features and the management tools. We have 16 wireless LANs. A key technology feature is the multi-radio meshing on the AP. So we can actually create meshes on the 2.4 radio and the 5X radio and go between them, which is a little different than Duo. In our Duo node, we had them on the separate radios. Now you can mesh across radios and have multiple meshes on the radios. So we have 4 BSSIDs and on-demand channel scan and auto channel select to help with interference. We have 802.11e QoS, and that's 8 Qs, commonly known if you did the Wi-Fi certification as WMM. We have a full-featured graphical user interface. So if you're familiar with the 7131 indoor, we basically ported that code to the 7181 and added all the enhanced features that we needed for outdoor, like high-powered radios, MeshConnex, and other features like a software electronic delve tilt on the antenna system, which we found is very important for outdoor deployments because you don't determine that until you're actually at deployment. So some security features, basically we have WPA2 and PSK, all the standard features in Wi-Fi. Encryption, we do AES encryption in the hardware And something that's very key is the inter-mesh encryption on the backhaul. We call that secure mesh with AES encryption. The authentication is 802.11.1x, and that's infrastructure client authentication, which is key in the Wi-Fi security world. Management tools, OnePoint Wireless Manager. We can do device discovery, inventory management, alarm and event management. The Google Maps feature is an important feature for outdoor environments. We can also do a click-through to RFMS that Bill mentioned earlier about the indoor-outdoor storage. We can do over-the-air upgrades, especially in very large outdoor networks. You want to be able to do that. And a typical element management system for FCAP, default configuration, administration, and performance and security. Let's talk a little bit about the product SKUs. We have 5 SKUs set up, and that's basically, we made them regional SKUs. You'll see that the first 2 SKUs, the HK1860A and the 1860A1A, are North American SKUs, an AC and a DC unit. The DC unit is a 48-volt DC. The difference between the North American SKUs and the international SKUs is we're node locking the 5.4 radio on the North American SKUs. And they also have power cords for the U.S. And all the power cords are flying lead. The HK1873A is a international SKU. It has a special power cable for EMEA in Australia for flying lead. And we have 2 other international SKUs set up for AC and DC also, and they have international power cords. What is in a 7181 product SKU? Think of it as everything you need to take that device outdoors. The adaptive panels come pre-assembled. If you look to the right, you'll see a picture of the actual 7181. All 4 panels come pre-assembled on the unit. If you look at the very top, there's a mounting yoke. That yoke will let you, that's actually mounted on top. You can actually disconnect it and mount it from the bottom depending on what your deployment scenario is. Sun shield is more of a decorative feature. You'll see on the very top of that box, you'll see the decorative sun shield. You can also take that sun shield and there's the same sun shield applied to the bottom if you want to cover up the cables and then snake the cables through the mounting bracket. Waterproof Ethernet adapter. One comes in the kit if you want multiples. If you're going to plug multiple cameras in, I would order an extra one. Regional power cords with flying leads because we know that outdoors everybody wants to plug into grids. There's optional ordering features in the catalog for plugs and things if you need other accessories. Some high-level breakdowns of the accessory pricing. I lump them into deployment accessories because you have to determine where you want to hang this. You want to put it on a pole or roof or against a building. Depending on how you want to mount it, you would order one of these typical mounting pieces. Think of these mounting pieces similar to the video cameras that you see out on the market. So we have, on that yoke, you have a 1 1/4 inch threaded pipe that you'll be able to attach the unit to. We've listed replacement accessories. These replacement accessories are if you lose things, if you want more inventory, or if you just want spare. Wireless Manager. We list Wireless Manager here. That's just to give you an overall view of what the cost for the managing system is for very large deployments. If you're doing large deployments, definitely recommend Wireless Manager so that you can do full upgrades outdoors. Otherwise, you could just use the graphical user interface that comes with the system. Make sure you buy that physical Maps license feature because that's the Google Maps version that we talked about. Okay, let's talk a little bit about competitors. So this is how we see the competitive landscape. We like to look across Cisco, and we've watched Tropos and Firetide do some introductions. Cisco hasn't announced an end product yet, but they've definitely certified the 1522. That they're using the Marvell chip in there. It's an end chip, but they haven't suggested they haven't announced an end chip. So what we noticed is that they're, remember Scott talked earlier about the nomenclature of 3x3 and 3x2? Well, they're actually doing a 1x3 on the 2.4, which is 1 transmit chain and 3 receives. So they're definitely taking advantage of the MRC gains on the 2.4 side. But you'll notice that they only have a 1x1 chain on the backhaul. So they basically took that box and FCC'd it for a 1x1 in high throughput mode for N. So also I want you to take a look at the total pricing. These are the MSRP pricing. When people start putting out press releases about particular nodes, they usually just like to put the box price. They don't tell you about the antennas that you need and the power supply to plug in and the other things that you need to do for deployment. For instance, Tropos, they've made an introduction. They have two nodes, the 6300, and I don't compare that to our AP 7181. The 7320 is more comparable to the 7181, and they're doing a 1x3 again on the 2.4. So they're doing one transmit chain and 3 receive chains on the 2.4. So they're going to take advantage of MRC gains on the 2.4, but notice again, on their backhaul they only did a 1x1. Again, they're doing dipole antennas. Remember Scott talked earlier about the self-shadowing and the interference problems outdoor? If you're not going to do dual polarization diversity outdoors, the chances of getting to that second data stream are very, very slim. Let's take a little bit look at Fireside. Okay, so I look at Fireside as a low power radio, 20 dB, 3x3 on both the 2.4 and the 5X, but it's only in point-to-point mode. They talk about meshing in their press releases, but it's actually in linear mode. Once you deploy these in linear mode, they're really just point-to-point, and there's no mesh capability and no access, client access. So for $68.95 MSRP, you can have a point-to-point solution. And you can actually take a look at the 7181, take a look at our 1 watt radio. So our conductive power is 1 watt, and our EIRPs are the max in North America, and we also can lower our power to the other European countries. Very key in 802.11n, integrated panel antennas. If you don't do something with your RF system, you're not going to get to that second data stream, which is very key in 802.11n. All those claims to fame of data rates, you have to get to that second data stream, and you got to be in a 40 megahertz channel to get there. So you can see that our price includes everything for $48.99 MSRP. I'd like to turn it back over to Scott to wrap up.
Great. Thanks, Bill. Thanks, Ro. And before we get into the question and answer, I just want to go back again. We feel we have the right solution at the right time. The 3 things we want you to remember is 300 megabits in the mesh layer to provide highest capacity in an outdoor network, 0 antennas for better coverage and no porcupine effect, and Motorola, the one company with one network, one complete portfolio. Before we get into the questions and answers, and I see Matt you guys have been real great submitting questions. He's sweating buckets over here trying to keep up with you. We probably won't be able to answer all of them today. We'll try to get back to you via email. But I would also encourage you to come to our free one-day training course on the 7181. We're going to have it in Chicago, Dallas, Fort Worth, Boston, out in San Francisco, and here in Lake Mary near Orlando. So there's a registration website that probably if you scroll down on the invitation to the webinar, it was also accompanied there. Now this is targeted for North America, VARs and Motorola people alike. If you can't find the registration site, email Lynn Ventimiglia, and that's the email alb002@motorola.com. Some of the things that we'll be covering is, positioning, standards and technology, hardware, software, providing a demonstration of the product, network planning, roadmap, and ordering process. So we'll also be including a session at the beginning on the point-to-point 800, which is being launched at the same time. And we'll also cover Broadband Planner, an overview of that and demonstration. So it's a full day. It's all free. We hope you can join us. So thank you very much. The other thing I would encourage you to do to get more information is to go to motorola.com/802.11n. We have white papers up there that go into deploying .11 in the outdoor environment. MeshConnex, we've got spec sheets, we've got a number of marketing literature up there, and along with use cases. So a lot of things we talked about today are on that website and available for you to view. So Let's take a look at some of the questions that we've seen. And Matt, what do you have for us?
So thank you very much, Scott, and thanks to everybody who's been submitting questions. If I didn't get round to your question, we will be gathering up the FAQ and presenting all the questions and answers in a document after the call, and we'll make sure people have an ability to get to that. What I've done, I've selected the top 5 or 6 of the larger questions that everyone was asking here. So I'm going to throw this out to our team here in Lent Mary. First question is, when would a VMM be available for the AP7181 so that customers can do mobility? And will we be qualifying MIMO antennas for that device? Want to take this? So I think Bill Rubino is going to answer this question.
So currently, as I had mentioned in my slides, the 4300 VMM is compatible with the 7181, and that's going to give you wireless broadband connectivity at mobile speeds. So this will be compatible in both a 4300 network and a 7181 network as well. Right now, it's too early to talk about having a .11n based VMM, but the current version of the VMM is going to give you some decent capacity as well, and it is supported on 12 volts DC.
So, let me add to that a little bit. This is Scott. Yeah, it is on the roadmap. We feel that the duo VMM for like a single police car or mobility, you'll gain a lot more throughput being in an end network, as we talked about having a BG client in the network. It will support MeshConnex for fast handoff. So there's a lot of value there, and with higher bandwidth and true mobility using that VMM. We anticipate having a VMM sometime next year that will be a .11n based, and we see that more targeted towards the mass transit market, where they're looking to run 6 or 7 cameras on a single train and feeding that back for the high capacity. So that's the story on the VMM.
Great, thank you, Bill, and thanks to Scott there also. A set of questions came in also on this topic. So will the AP7281 have an adaptive AP capability and be managed by our current controllers, such as the RF7000 switch? If not, will RMS be able to push configurations to AP71s individually? So I think folks out there are looking for an elaboration exactly how we intend to do our indoor-outdoor solutions. So what are the components that will make up that solution, and how do we do seamless roaming as well?
Right. So Bill went through quite a bit of that. I don't know when this came in. So we do anticipate supporting adaptive AP, probably in our second release. We'll be mapped closer to the 7131 4.x release, which will support that also. So as Bill showed in the diagram, a lot of the interoperability can be done through a wired connection, which in reality is what you will deploy anyways. It would be unlikely that you'll be deploying a mesh network outdoors that is only getting its backhaul connectivity from a over-the-air mesh link on the 7131. You'll be terminating that outdoor network with a wired connection. That will go back up through your layer 2-3 switch. So we anticipate that will cover 99% of the deployments. There's really only a couple of features that we would be looking to take advantage of on the AP switch. I mean on the RFS switch, but we do have plans on supporting that capability in our second release.
Great, thank you, Scott. Our next question, we had a lot of questions about air defense. So folks wanted to know, does the AP7181 work with air defense as a network sensor?
No. That's the short answer today. We do have some capabilities in the 7181 to be able to detect rogue APs. The solution that we believe is actually more economical is to utilize the 7131 in an outdoor enclosure as a sensor node and deploy those as a 4-to-1 ratio. That will give you all the air defense features and capabilities at a much lower cost than using a high-powered 7181 just as a sensor node.
Great. Well, thanks, Scott, again for the answer to that question. Our next question is about meshing. So this is in two parts. Can an AP7181 mesh with an AP7131? And if so, how does that actually work? How do you do that?
So that's, I guess I'll take this one too. So I'm on a roll. Yes, it can mesh. The AP7181 supports both MeshConnex that we talked about and spanning tree. The AP7031 today supports AP7131 product management group. The AP7131 sometime next year. But today, out the chute, you can mesh using spanning tree.
Okay, so we're coming up to our last couple of questions here on our Q&A session. Another very popular question was, when could we expect a 4.9 version of the 7181? And in the period between now and when we release that product, how would we position 4.9 with our customers?
That is slated for, we have a release 2 on the roadmap, which is slated for first half of 2010, and we have it'll be a tri-radio solution, so you'll have additional SKUs added, which will be a tri-radio solution. And what was the other part of that?
How do you position it?
And how would you position in the short term for customers who are looking for N in the 4.9 space?
Yeah, I would definitely position those for the public safety customers, because of what we're going to do on those nodes is we're going to have meshing capability across the radios now, and also on the 4.9. So,
well, the other piece is, again, that's why we presented the Duo compatibility. Today, Duo supports 4.9. So a customer looking to start deploying a network now can do that with 4.9 on the Duo product. We'll have full compatibility. They can have 4.9 VMMs for mobility. That's primarily used for public safety. Then as the 7181 Release 2 comes out, you can deploy those in the 7181s in high capacity, high throughway areas, and reposition the Duo nodes out to the edge of the network so that you have connectivity and where there's less capacity needed.
Okay, so I'm going to move on to our final question because time is rapidly running out on us here. What are our plans to obtain FIPS 140-2 compliance for the AP7181? Again, that was a very popular question here on the Q&A.
okay, we're slating that for Release 2. We have that slated on the roadmap. As everybody knows, we're getting 7131 compliance on the FIPS. We're going to be able to take that 4.x baseline, port it over to the 7181. We'll probably release the hardware first, just because the FIPS compliance and certification takes like 3 to 6 months and paperwork to do. So we'll be FIPS compliant in Release 2. We will GA the hardware and then follow with the cert.
Okay, so that's the end of our Q&A session here. As I said before, we will make sure that the full Q&A is documented and everyone will be able to see that online.
Thanks, Matt. Thanks, Ro. Yeah, it seemed like a lot of those questions were Release 2, but you actually hit the top 3 or 4 features that are in Release 2, so good questions. I want to thank everyone for attending, and I hope it was worth your while.